we are going to talk right now about exponential functions. This is going to address several of our standards. This one is exponential decay. I'll do another video on exponential growth. We'll go through a bunch of the same things. Okay, so we're going to say you buy a new MacBook for $1,300. Every year it loses 30% of its value. We want to make a table of values for the first 6 years, write an equation of the value of the laptop after X years, and then find the value of the laptop in 10 years. So we're going to make a table first. This is years, and this is the value of the MacBook. So when you buy it, which is year 0, this is $1,300. Okay, in year 1, I'm going to take that $1,300, and there are two different things I can do with it. So one of the things that I can do is I can do 1,300 times 0.3, that's $390. It loses $390. So I can do 1,300 minus 390. Sorry, hold on for just a second. So that would be $910. And I can do that every year, but that's kind of a pain. So what I'm going to do instead, and this should sort of make sense to you, I am going to, I'm thinking about the amount that I have, not the amount that I lose. So if I lose 30% of the value, that means that I'm keeping 70% of the value. So to go from here to here, instead of doing times 0.3 and then 1,300 minus that, I'm just going to multiply by 0.7. And that's the key for what makes it an exponential function, is I'm multiplying all of those times together. Okay, so to get year 2, I'm just going to do 910 times 0.7. Just kidding, hold on, sorry. 910 times 0.7 is 637, would be the value in year 2. In year 3, I'm going to multiply that by 0.7 again. That gives me 445.90. In year 4, it would give me 312.13. In year 5, it would give me 218.49, and then in year 6, it would give me 152.94. All right, so at the end of 6 years, its value would be $152.94. And I'm just rounding that to the nearest penny because it's money. So what I'm doing over time here is I'm taking what I start with, $1,300, and I'm multiplying that by 0.70 to the x. So every time, for every year, I multiply it by 0.7 again. So for 6 years, I multiplied it by 0.7 to the 6th. So that's my equation. The basic equation for an exponential function is y equals a times b to the x, where a is your initial value and b is your growth factor. What makes it an exponential function is the variable is the exponent. Okay? So we're also going to look in this chapter at things that have an x squared. That's not an exponential because the variable is not the exponent. All right, let's erase that. That's something different. So now I need to know what the value of the laptop is going to be in 10 years. So I'm just going to take this equation, and I could just multiply by 0.7 for years 7, 8, 9, and 10, but it's actually quicker to do it this way. So let me get my calculator together. So I'm going to do 1,300 times 0.7 to the 10th. And at the end of 10 years, my laptop will be worth about $36.72. And that seems like it's not very much because it isn't. But when you consider that in this first year it lost almost $400, and then from year 6 to now, to year 10, it only lost a total of less than $80, right? So then that's part of how you know it's exponential. Okay, so then the last thing I want to do is just look at how we could graph this. Here, let me erase. I'm going to look at my table to help me with that. Let's make this eraser nice and big. So I'm going to erase all this equation stuff. Again, you can always back the video up to look at that part again. But to graph it, I'm just going to mostly put first quadrant on here. So I'm going to start at $1,300. So I'm going to be like, okay, 5, 10, 15. So $1,300 is going to be right here. At the end of year 1, we're going to be at like 910, which will be right around there. The end of year 2 will be at 637, so that's going to be around here. And then 445 is going to be like right there. And then 312. And then 218. And then 152. So you can see that it's kind of going to flatten out over time. Yeah, so it has that curve that we're used to seeing for exponential functions. Yes? All right, so the basics for exponential functions are, let me get rid of everything here. So for exponential functions, our basic equation is y equals a times b to the x. A, again, is that initial value. That's our y-intercept. And b for this one is our multiplier. That's sometimes called your growth factor or your decay factor. Okay? What we're looking for in our table is that we're multiplying by the same number each time. So remember in that decay example, we were multiplying by 0.7 each time, 0.7, 0.7, 0.7, 0.7, 0.7. Multiplying by that for each level of our table. And our graph for this is going to have this shape. Okay? This will be 1,300 for this graph. And then we multiply by 0.7 to get all the rest of the numbers. Those are the basics of exponential functions. And then, the other thing is just to be able to answer those questions. So if I said, like, what would happen in 10 years? You would look for what would happen in 10 years. You just make your exponent 10. If I asked you, like, when does the value of that MacBook first get to be below $100? You could just continue your table until you get to $100. Keep multiplying by 0.7. All right? So that is exponential functions. That's pretty much everything that you need for those. I'm going to make 2 more videos on exponentials. One is going to be an exponential growth example, and one is going to be comparing exponential and linear functions to decide which one it is. That's it for this video. All right, thanks guys.